Hello friends, let us understand Kirchhoff law for electrical network. Now before understanding what is Kirchhoff law for electrical network, let us first understand what is the significance of Kirchhoff law, importance of Kirchhoff law. Now this Kirchhoff law is basically used to find the unknown entities, unknown values of current, unknown values of EMF, unknown values of potential difference across a resistor in a particular complicated circuit. So that's the reason why this law is considered to be very important. Now this Kirchhoff law is divided into two. Kirchhoff's first law. Kirchhoff's first law. Now what does Kirchhoff's first law says? This is a complicated circuit in which current I1 is flowing, I2, I3 and I4, I5 and I6, right? And this is a junction. Okay, it says that the amount of current which is coming towards the junction is equal to the amount of current moving away from the junction, right? So see here, in this complicated circuit, what is the amount of the current which is coming towards the junction A? I1, then I2, I3, I4, right? This is the current which is coming towards the junction, which is point O. This has to be equal to the amount of the current which is moving away from the junction, out of the junction, which is equal to I5 plus I6, right? So what this Kirchhoff law says, the amount of the current which is coming towards the junction is equal to the amount of the current which is moving away from the junction. So the same equation I can write I1 plus I2 plus I3 plus I4 minus I5 minus I6 is equal to 0. So I can say summation of the current is equal to 0. Let us understand this. Summation of the current at a particular junction is equal to 0, right? What is the summation of the current? I1 plus I2 plus I3 plus I4 at the junction minus I5. Why? Because I5 is the current which is moving away from the junction, minus I6 is nothing but the current which is moving away from the junction, is equal to 0, right? So Kirchhoff's first law says that the summation of the current at a particular junction is equal to 0, or we can say that the amount of the current which is moving towards the junction is equal to the amount of the current which is moving away from the junction. This Kirchhoff law, first law, basically it has to law of conservation of charges. This law obeys law of conservation of the charges. That means it says that no charge is accumulated at this junction. Whatever charge is moving towards the junction, the same amount of charge is moving away from the junction, right? I hope you have understood Kirchhoff's first law. Let us take an example of Kirchhoff's first law. Example. I am taking a complicated circuit. 5 ampere of current is coming from this branch, 3 ampere of current is coming from this branch, 2 ampere from this branch, right? This is how the current moves. This is how the current moves, and the current finally which is moving through this branch is I. Now the question is find I. Now this particular circuit looks very complicated. We don't know what is the amount of current which is passing through this branch, this branch, this branch, this branch. We don't know, it is not given. But what does Kirchhoff's law says? If this is the junction point O, it says that the amount of current which is coming towards a junction is equal to the amount of the current which is moving away from the junction, right? So what is the total amount of current which is coming towards the junction? It has to be equal to 3 ampere plus 5 ampere plus 2 ampere, right? So the total amount of current which is coming towards the junction is equal to 5 plus 3 plus 2, right? Which has to be equal to I. So that means I is equal to 10 ampere, right? So that means without using Kirchhoff law, it would have been very difficult for us to find the value of current I. However, using Kirchhoff law, it becomes much more convenient for us to find out the answer. I hope you have understood the session. Now we will learn Kirchhoff's second law.